Hello everyone, I am Brandon Ordoñez from ECE31 and today I'm gonna perform our experiment number 2 for our Digital Electronics 2 laboratory, which is entitled Digital Input. Brandon's Vlog.
The objectives for this experiment are to learn how to create a project and build a project, to understand how the final code program to the microcontroller works, to create a simple code for controlling LED. Now, let us proceed with the experiment. First, open MPLAB X IDE and then create new project. Standalone project and type pic16f 18875. Click next, and for the compiler toolchains, click XC8. Choose your file name and your project destination, and click finish. Afterwards, click tools and embedded and MPLAB code configurator. Now, let us click save. So for the experiment, we would be clicking output A4 and B4. So when you click those buttons, it should turn green, and the buttons above it should turn yellow. Now go to pin module and remove these. Rename LED and switch. So for the LED, only the output box should be ticked, and for the switch, only the WPU box should be ticked. Then check the oscillator should be H-pin TOSE, and the high frequency internal clock should be 4 MHz, clock divider 4, and low voltage programming enabled should be checked. Click generate. Now after you generate, go to projects. Under your file name, go to source files and you should see main.c. From here you would edit the code. Now our program should enable the opening and closing of the switch if along with the LED output. So if the switch is turned on, the LED should be turned on. If the switch is turned off, the LED must be turned off. So let us and after typing your code, click build. And after build is successful, we could now go to MPLAB IPE. After opening MPLAB IPE, you should now proceed to programming your microchip. Let us proceed with programming the microchip. Let us put our microchip, our integrated circuit, and the pick kit tool, and lock. Connect your pick kit to your personal computer. Now that we have connected our pick kit to our personal computer, it is now recognized by the system since it shows pick kit 3, and let's click connect. Okay. And there would be a warning. So click click settings, advanced mode, and enter microchip. Edit the voltage level to 3.125 and enable power target circuit from picket 3. Now let us browse for our hex file. It would be found in your project folder. Click this, default, production, and there would be your hex file. Now click program. Okay. Now that programming is complete, let us now apply our integrated circuit to our main circuit. So click disconnect. Now that programming stage is complete, let us now put our integrated circuit to our main circuit. So let's now build the circuit. Since we used RA4 as our output, we would connect the LED and the resistor to the said output. So let's connect this with the pin for RA4, which is pin 6. Next, connect the switch to RB4. So this is the switch. It has a positive and a negative terminal. One terminal would be connected to the RB4 pin, which is pin 37. Here. While the other terminal of the switch will be connected to the negative terminal. Okay. Let us add the ground for the output and add the VDD pin 11 to the positive terminal. Another VDD pin 32 to the positive terminal. Next, all the VSS should be placed on the negative terminal. The pins for the VSS are pins 12 and 31. After plugging all the required connections, let us now place our voltage source, which is a 5-volt voltage source. Positive terminal here, positive red, and negative black. Now, let's check. Positive terminal, the switch, VDD, and VDD to the positive, another VDD to the positive, VSS to the negative, and another VSS to the negative, ground of the output, ground off the switch, and then we are set. Now, let us turn on the power source and see if the circuit will work. So if we press the switch, the LED turns on. And if we press the switch again, it turns off. On, off. So the second part of the experiment is to modify the code such that the LED will blink every 2 seconds if the switch in RB4 is pressed. So let's modify the circuit. Delay underscore. So So it's every 2 seconds, so it's 2000 milliseconds. And toggle. So now let us build. It is now built successfully, so let us reload the hex file and let us now put our integrated circuit and program it. So now we would program our integrated circuit using our picket tool. So first, let us remove the IC from our breadboard. And let's set this aside. Now let's get our picket and lock and plug. After plugging our picket, let's open MPLAB IDE and click connect. Okay. Check parameters, still there. And click program. No need to reload since we already reloaded it back in MPLAB XIDE. So now programming is complete. Click disconnect. Now that we are finished programming, let us now put our integrated circuit back to our breadboard. So for this part, by pressing the button, the LED should blink for every 2 seconds. So let us try. So as you can see, the LED turns on and off every 2 seconds. So if we turn off the switch, it remains unlit. So for the third part of the experiment, we are asked to create a program that lights the LEDs in RA1, RA2, RA3, and RA4 after the button is pressed in 1 second in RB4. So let's open MPLAB XIDE, go to resource management since we would have additional outputs. Click port A1, port A2, and port A3. Check for the oscillator select. This information should be the same as before. Go to pin module and remove the check and the analog boxes, and the check should be for RA1, RA2, RA3, and RA4 should be on the output, while the box on that is checked on RB4 should be on under WPU. So let us edit the names: LED1, LED2, LED3, and LED4. Now let's click generate. After generation is complete, go to main C and edit your code. So for the code, we will use LED1 underscore set high parentheses, and this should be 1000 second shoot since we are asked to delay the LEDs by 1000 millisecond or 1 second. Edit this as well. LED1, LED2, LED3, LED4. Then click build. So after build is successful, reload, and then proceed with connecting your picket again to the PC. Now let us program our code to our integrated circuit. First, let's remove the integrated circuit from our breadboard and set this aside. plug, and connect your P kit to your personal computer. So after connecting your P kit to your PC, click connect, open MPLAB IPE, and okay. And click program. Since programming is complete, click disconnect.
Now that the code is programmed to your integrated circuit, disconnect and lock, and then modify your breadboard schematic. So first, let us remove all of these wires. So first, let's plug our IC, and let us add 4 LEDs and 4 resistors, since there should be 4 outputs. And then your circuit. So first, let's connect all these outputs to the ground. And then connect them to their respective input pins. So now let us try our circuit. So if we press the switch, it should turn on after 1 second. 1. And it remains open. So if we turn off the switch, the LEDs remain unlit. So let's turn it on again. 1.
So for the last part of the experiment, we would modify the circuit such that they turn on 500 with 500 seconds interval, 500 milliseconds interval. So let us build. After build is successful, let us reload the hex file and plug in our picket.
So we would now be plugging our picket. So first, let us remove our integrated circuit from our breadboard. And let's get our picket. So now let us load. Let's plug our integrated circuit to our personal computer.
Now that we have plugged in our picket, let's go to MPLAB IPE and click connect. Okay. And afterwards, click program. If programming is complete, click disconnect. And let us now apply our programmed integrated circuit to our breadboard.
So after programming our PKit, let's disconnect. Now, let us plug our integrated circuit back to our breadboard. Let's try to connect our power source. So turn it off. The LEDs don't light up, and if you turn it on, the LEDs light up in a sequence wherein the first one lights up, the second, and the third, and the fourth, and afterwards all of them remain lit. Again, let us try. These are the conclusions and recommendations for this experiment.
Same as before, the flow followed by coding first at mplab xide and then inputting the program code to the integrated circuit using mplab xipe, and lastly applying the programmed integrated circuit into the main circuit used for the experiment. Conclusions and recommendations. The experiment involved the use of a switch as a way to control the output of the LEDs used for the circuit. By having an input, one is able to turn on and turn off the resulting light of the circuit. Aside from the use of a switch, the experiment also enabled the use of multiple outputs, which are also represented by different LEDs. These LEDs were controlled by modifying the code and calibrations used for the mplab xide software. Also, it was discovered while mixing up the codes that the toggle code only enables the LED to be turned on for a certain period of time, while set high code enables the LED to hold its state of being lit. I recommend that you check the wirings and placement of pins during the circuit applications process to avoid errors and to achieve expected results. I also recommend that you try on different codes as a way of exploration for different outcomes of a coded program.